All right, ladies and gentlemen, we're moving on to example 5. We're going to randomly select 3 cards from a deck of 52 playing cards. It's normal. Sometimes there's jokers in there. That would be if you have more than 52, but if it says you have 52, that means the jokers have been taken out. What's the probability that all 3 cards are hearts? Now, a couple things about a deck of cards. There's 4 suits: hearts, clubs, diamonds, and spades. Each suit has 13 cards because 13 plus 13 is 26, plus 13 is 39, plus 13 is 52. They go from 2 all the way up to ace, or if some people like to say ace 2, treat the aces like 1, depends on how you want to do it. There's a 10, jack, queen, king in there as well. So there's 13 cards of each suit. All of this is relevant to try and think of the idea that we're going to pull 3 cards of the same suit. So in example A, we replace the card before selecting a new one. This means that the selection of each card is independent of the other one. In other words, the first card did not change the probability or possibility of pulling the second card. So if we keep that in mind, we can use the idea of P, the probability of A and B and C is the same thing as the probability of A times the probability of B times the probability of C. Now that last part's new, the probability of C being added in, and what it indicates is the probability of all occurrences when they're each independent is the same thing as multiplying the probability of each probability independently. Okay, so if there were 5 things we were trying to do, we find the probability of all 5 of those, we multiply them together, and that's our total probability of A and B and C and D and E. So let's get going on this one, get it finished up. The probability of A is the idea that the first card we pick is going to be a heart. That means that we have a 13, there we go. We have a 13 and 52 chance. Now, if we wanted to, we could simplify that to 1/4, I believe it is. Yeah, 1/4. Because again, like I said, or like I was counting earlier, that's one reason to keep this in mind. We have 13 cards that are hearts. We have 52 total cards in the deck. So we have a 13 out of 52 chance. Well, 13 and 52 simplify, or 13 over 52 simplify to 1/4 because it takes 4 groups of 13 to get to 52. So that's what I'm going to use here, 1/4. Now, we put that card back in the deck, so we still have 13 hearts in the deck, and we still have 52 total cards, so the probability of pulling another heart is 1/4. And we do that again. We put the card back, we draw again, there's still 13 cards, or 13 hearts, and there's still 52 cards, so we get 1/4. So 1/4 times 1/4 times 1/4 is the same thing as 4 cubed, or yeah, 4 cubed. Now that's 1/64. Now that is about 0.016 or 1.6% chance of pulling a heart out of a deck of cards, putting the card back, pulling another heart, putting it back, pulling another heart. We have a 1.6% chance. Now, B changes the situation. B says you do not replace the card. So we're going to pull out a card. What's the chance on the first time? It's 1/4, like we said before, because you had 13 cards and 52 cards out of 52 that you could have chosen from. But we're not putting that card back. That means we now have 12 and 51. So it's a 12 out of 51 probability for the second draw to be a heart. Now on the third draw, we've taken that card, we've set aside, we did not put it back in the deck. So now we have 11 hearts in the deck and we have 50 cards left. So when I multiply all of this out, and then I'm going to be able to go through and simplify and do all that, What I find is I have 1/4 times 12 over 51 times 11 over 50. And again, when I multiply it out, I get 11 over 850. That's after simplifying and everything else. By this time, you should be able to do that pretty well on your own. So that's about 0.013 or a 1.3% chance that I'd be able to draw a heart, not put the card back, draw another heart, not put that card back, and pull and draw another card. So what we find is the probability of A was 1 over 64. And what I mean by the probability of A this time is the probability of small a, meaning we replace the card each time and we pull a heart. And we divide that by the probability of B, or small b in this case, the probability that we were able to pull a heart and not replace the cards. And that was 11 out of 850. When we do that, we get it's about 1.2 times more likely to select hearts. I don't know why I said when here. When you replace, that's why. I'm just going to say when replaced, then not. Whew. I had to look at my notes real quick because I'm like, I don't know what I was supposed to be putting there. So we can tell the difference or how more likely one thing is over the other. All we have to do is compare them, and how we compare 2 ways, either through equal or division. In this case, they weren't being equal. We had 2 different instances. So we're comparing to see what chance one would be more likely or a percent chance higher. It's actually kind of just a potential increase, okay? So increase or decrease. Do we have a better chance or a lower chance? And we just take the probability of A divided by the probability of B. And in this case, we got it's 1.2 times more likely to select a hearts when replaced than not.